Okay, so I started the recording. Um, so I guess I'll start by going through the plan for today. As you can see, the plan is for 2 hours. It might take longer or shorter than that, depending on, you know, a lot of different factors. I'm not sure when we're gonna finish, but I'm planning to finish at 6 p.m. And we'll also have prayer break as well at around 5:30, depending on like how things go. Um, I didn't consider that in the plan because we changed the time a few times, so it's no worries. We'll figure it out though. So, um, welcome everyone. I'm Hassan Al-Lail. Um, I'm 18. Um, I've been programming using processing for over a year now, but I've been programming with other languages since I was in fifth grade. I'm a senior in high school now, and I'm glad to have you guys attend this crash course. It's going to be very beginner friendly, so don't worry if you don't have a lot of experience in programming. Um, you will, though, need a laptop so that you can get started. Um, and yeah, let's start looking through the plan. So, the first 20 minutes is going to be an introduction to the art of code, or the art of programming, as I like to call it, where we're going to look at some examples of previous projects I've made and the examples we're going to create, actually. These two. We're going to look at them, um, including other examples such as the Mandelbrot set, which is quite a famous, um, you know, how can I say this? Quite a famous piece of art, you could say. Um, then we're going to kind of briefly talk about chaos theory, Lee-Sajou curve, and other random sketches that I created. And then we're going to have a 10-minute break so that you guys can download processing and get everything set up so that you can start programming. And then we're going to run through the basics of processing, which include an introduction to functions. I'm not going to create functions, just look at them. Variables, some other visual functions in processing, and then how the program flows. And then we're going to create two example projects, which you'll see very shortly. The first one is a random box program, which is going to be this, and it's going to create a new, you could say, a new image every time you run the program. It's completely randomized, so that's what I really love about it, the random aspect where it's going to have different colors, different shapes, different sizes. Everything is going to be randomized with this. And then the other project we're going to create is this one, which is Harmonic Oscillations, as I like to call it. There's no official name to these. It's just what I called them because these are projects I created on my own. And we're gonna create these together. So yeah, let's get started looking at the example projects just to get you guys a little excited on this. Some of them might be very complicated or on a very high level, but I'm sure that if you guys are ambitious about this, if you guys really, really want to learn how to program and work with processing especially, you can get to a level where you can create them on your own very quickly. So in a few months. Some of these projects were some of the first projects I created, actually. So you have to get excited about it. So here's the first image I want to show you. So I have a set of images that I want to show you guys that are my examples of some of the projects I created. This is the first one. And as I said, this is Harmonic Oscillations. It's basically just the line that goes around, and it literally draws this in front of you. I actually still have the project open, and it's here. And I can show you guys how it draws itself. It's basically a painting that literally draws itself in front of you. And you can change all of these different variables to change how the painting looks. So for example, I can change this to 5.333, and it would change the way the painting looks. The drawing process might be a bit similar, but you can change all of these variables to create your own image, basically. So it finishes quite quickly. And here you have it, an image of your own. So this is what's beautiful about programming, especially art with programming. It's that you can change things ever so slightly and get very drastic differences in your end result. So it's quite exciting, especially when you get to a point where you create 100 images in like 2 minutes because of randomization and everything like that. And at a certain point, you'll be able to create animations and have the things flowing in very beautiful patterns. But that's a bit high level, so you can get to that later on. For now, though, actually, this is an example of something you can animate, this one here, but animating it is a different process than just creating it. So moving on to the next project, I've already showed this to you guys. It's the random box project, as I'd like to call it, because it draws all of these different boxes with many, many different colors. As it turns out, it's one of the shortest projects and also one of my favorite projects because of how quickly it can be created and how nice the results can be. Moving on to the next one. This is an image filter that I created a while ago. It's really simple to create. We won't create it today, but I'm planning on creating a simulation course, a full simulation course, where we most likely will get into image filters and creating filters for images. And this one is probably going to be one of them. It's a little creepy, but it's still a nice filter and it's quite easy to create. And as you can see, it's actually just white and black. Those are the only two colors, but different densities of these black dots make different regions look darker or lighter. And it's actually called a dithering filter. So that might be a familiar term that you guys know. Looking at the next one, this is a very nice example of recursion in programming. Again, we won't create this, but I plan to get into it in another course. But you can see how easily you can get very beautiful images using code. It basically draws a triangle and then draws multiple triangles inside of it. It actually might be easier if I open the original project, but I don't have it open right now. If you give me a second, I can just open it. It's not that long, but of a project, but it can give you some really nice results. As you can see, you start off with one triangle, and then if I click my mouse on the screen, it draws another triangle inside of it. If I click again, it keeps on drawing, or it keeps on getting, these triangles keep on getting smaller and smaller. And eventually, of course, we get the same pictures that I have on the right. But if I can keep going, but at a certain point, it just becomes a white triangle because you can't see all of the small details. But I just find it fascinating how you can draw all of these beautiful images with, an algorithm like this. It's like 39 lines or something, and you can create really beautiful images. And this is just the bare bones of the project. I think that the real artistic aspect of a project comes after you create the actual project itself and start changing colors, start changing the way things are drawn, start playing around with variables, playing around with equations, and then after playing around for a while, you're gonna get these beautiful images. Enough of this project. I spent quite a bit of time on that. And here's another project. It's not that impressive, but it's just an example of using text in a project to create a cool effect. Um, it's kind of, how can I say this? Cringy, you could say, but it just, you can like put inspirational quotes like this, and I think it looks cool. Not necessarily very impressive, but it kind of looks cool, and it's using text in an artistic manner. So that's another thing you can really do easily with code. And after you create it once, you can use it however many times you want, forever, basically. So yeah. Um, Moving on to the next one. This project, as I'd like to call it, psychedelic waves. I was inspired by a website I saw on the internet that had this as their background, and then I wanted to create something similar to that. And this actually flows, but I didn't want to show the video because it would be very blurry on the stream. I thought it might be better to show just a still image. But yeah, you can see how this kind of looks like rainbow liquid, basically. And it just shows how easily you can create these beautiful, beautiful patterns. And it actually uses something called Perlin noise, which is used a lot for procedural generation. Like if some of you are familiar with Minecraft, Minecraft uses noise, Perlin noise, or maybe Qubit noise, I'm not sure, to create its world, and that's why, it's flowing. I don't have a lot of time to explain what Perlin noise is, but it can be used to create very nice procedural images, or used in video games as well to create procedurally generated worlds. And here's the next one. This is a fractal tree, but with a little randomization. I don't think I actually have. I don't think I prepared a normal fractal tree, so I can. I guess I can search that up. So this is a fractal tree. You can see it here. And basically, you can have it be randomized and colored in different ways, and you get, as expected, some beautiful results. Here's another example. This one kind of looks more natural because of the green tips, I think. The other one had kind of a purplish or pinkish tip, so it didn't look too natural. But this one really looks natural, except for the branches, of course. If the branches were brown, it might look nicer, but it's nice nonetheless. Moving on to the next one. This is actually one of my favorite projects, and it's actually a black hole filter. And from now on, actually, the projects are going to get a bit more complex and are more recent projects of mine. But I think they are the coolest. Once you get to this level, the projects really start becoming really, really beautiful. And you can see, I'm not going to play the video because it's going to be laggy, but I can scroll through it, or I can play it once and then scroll through it. So yeah, you can see how I called it a black hole filter because it takes any image and it has an effect where it kind of sucks in all of the pixels to the center. So you can see it just sucking in all of this. It's not very realistic. It's not very scientifically accurate, but you can be the judge of whether or not it looks nice. So this is how another way in which you can manipulate images with code and make it look really nice. Here's a still image of a black hole filter, just so that you can see it. And this one actually had warped edges, so that's why it looks a bit twisted. There is, however, something here, like there are dots here that show up, and it's actually not meant to happen, but I couldn't find a solution to that, sadly. But it's still a cool effect. It's not very realistic, but it's really cool. Um, Here's something else that's cool. This project is a Perlin noise flow field, which basically spawns particle and has them move around and have these really nice flow fields. These are called flow fields. And they're basically like connecting lines that flow in the same direction. And this is actually my phone's screensaver. So that's why I created it. But let's move on because the details don't really matter. This is another example of how you can use Perlin noise flow fields. And the difference between these two projects is actually just changing a few variables, like literally changing a few variables, and you get drastically different effects. So again, it's one project that can give you infinitely many, images to share and create and use on your own or send to your family members or whatever you want to use them for. Moving on to the next one, this is actually the Mandelbrot set, but zoomed in because I think it looks much better when it's zoomed in. And you can actually see here, I'm not sure if this is Julia set or Mandelbrot set because they're quite similar, but you can see how this is basically a never-ending so someone told me that we're over break time, but we're not actually. We started at 4:10, so everything was pushed forward 10 minutes. And it's a very flexible time, so don't worry about like overlap. It's very flexible. So you can see how this is a never-ending pattern. It's actually more mathematical than programming. It's a mathematical phenomena. I don't have too much time to explain, as I said, but it's a never-ending cycle, and you can, again, create infinitely many images using this. So this is how you could take a simple, or not that simple, mathematical concept and transfer that into code, into a program that creates images like this. I would show you more details, but again, I don't want to scare you away with them. Here's another example that's grayscale. It's a different part as well. So yeah. And you can see how this is basically a never-ending cycle. If you would zoom into here, of course this is an image so it wouldn't show, but if you zoom into here, it's going to be an infinite cycle of zooming in. And eventually you're going to get the same recurring pattern over and over and over again. Of course, as long as you have the proper hardware to do that. And you can see how there's this big part of this pattern, and then there's another smaller one here, and another smaller one here, and another smaller one here. And it's just a never-ending cycle of, this same pattern. And personally, I think it's very, very beautiful. Moving on to the next one. This one is different. It's not really artistic, but more of a game. I just wanted to include it because why not? But this is a very simple snake game I created using processing. So if you're looking to get into game dev, this might be a good start to understand the underlying concepts behind game dev, and then you could like move on to more developed software like Unity or Unreal Engine if you want to do that. But if you want to get like a basic grasp of game development, you could start off with processing. So I just wanted to put that there. Here's a project I made 8 months ago or so. Before I knew what it really was, I was just messing around with code, and I came to this result. I now found out that it's called the 𝓟𝓻𝓸𝓰 curve, but it's basically I can't really explain it unless you're familiar with it, but in a certain way, it's basically drawing a circle or an ellipse to be more accurate, but so many times that it makes a square pattern. So yeah, this is basically, you can think of this as an infinite set of ellipses. Not really ellipses, but shapes close to that. Actually, after creating this project, which is the Harmonic Oscillation project, it could give you a nice start to the 𝓟𝓻𝓸𝓰 curve that you can then explore on your own if you would like. Moving on, here's another one where I have two boxes overlapping rather than just one with two different colors. Again, this was before I knew what the project really was and I was just messing around with it. But yeah, moving on. This is my latest project and one of my favorite projects as of yet. It basically draws the electric field line of any configuration of charged particles. I know that that sounds sciencey and advanced, but it's much simpler than you think. It's just about like setting up the system in which particles react with each other, and then the rest is just processing. It's just art, playing with colors and stuff like that. Again, I don't have much time to explore it, but it can basically draw the electric field lines of any configuration. And you can see how the field lines flow. Here's another example, but this time this is with like a square grid. And actually, I forgot to mention that I made it so that the blue particles are positive particles and the red ones are negative. So this is in a way a dipole, an electric dipole. And if you zoom out, actually, I don't have an image zooming out, but if you zoom out, actually you might be able to see it here if you twist your head. This kind of represents the electric field lines of a dipole from far away. But that's not important, it's kind of irrelevant. Anyways, this kind of ends the section where I give you an introduction to art with code, or the art of programming, as I'd like to call it. So now we'll have a 10-minute break to download and install processing, and then just for you guys to kind of get a breather before we start actually coding. So this is where the real part of the crash course comes in, where we're gonna start exploring the basics, and then we'll start with these projects. We will have more breaks in between, so don't worry about like finishing everything now. But during this break, I want everyone to get a laptop, and then once you do that, go to processing.org and install processing. You can just search up processing on Google and find this, or if you're on your phone, or you can open the link. So yeah, I'll send the link in chat so that everyone can open it. So please open this link and download processing. The installation is really simple. You just open the installation wizard and then it's going to automatically install it. So let's take a 10-minute break so that everyone, or actually 5-minute break for you to get a laptop, and I'll actually be going as well. And then, I don't know, is it a zip file? I'm not sure it's a zip file. Okay, it's good that it opened on my other screen. Oh no, I don't know why it's a big file. It's usually much smaller. It's completely free, by the way, completely free. So you don't have to worry about that, about paying anything, but they do run on donations, so you can donate here if you really like the program. Because they are doing this all for free. You can install whatever for whatever device you have. So if you have a Mac, you can install it there. Linux, Windows 64-bit, or Windows 32, whatever you have. I don't know why I installed this one, so no, that one. But yeah, you can download whichever one you need. So let's take a 5-minute break, and I'll see you guys in 5 minutes, just so that everyone gets the laptop, and then if you need more time to install it, then you can just say so. So yeah, come back at 4:40. if anyone has any questions, you can just ask me if you'd like about processing, about projects. You can raise your hand if you would like to speak, and I can unmute you. Yeah, okay. As I said, we're gonna wait. I'm gonna wait until like everyone is okay with it. Um, I think you actually have to open the file. So if you open this here, you just open just any file. I guess I'll open this one. You can just put this in here. Just extract this. It's gonna download in your downloads folder by default. So after it exports, I put it in a random file. You should put it somewhere good. I don't remember the file being this big. I thought it was much smaller. At least when I installed it, it was. Or maybe my internet was faster. I'm not sure. So yeah, it might take a little bit of time to install. I'm not sure why it's taking forever to extract. It's probably because I have 20 things running. I have OBS because I'm, oh no. I have OBS because I'm recording, and I have Zoom because I'm sharing my screen. So that might be why it's taking a long time for me. Anyways, after you do this, it's basically installed. You can just open this, and it opens immediately, I think. So yeah, it's just the zip file that you then open. And this is the actual program. So you don't run the zip. So yeah, now you can see that I opened the newest version. I'm actually check if this is better than mine or not. Yeah, it's not a new version. So yes. You don't have to, it's just one file. So if you look in the zip, it's just one file inside of the zip. So you can just, you could right click the zip file and then, where is it? I'm not sure where it is, but this is literally the whole program. You open this one, so not the other one, and you don't have to install anything else. Yeah, run processing, and then it should open the IDE. So you're not installing anything, you're just like downloading it. You're basically installing it without like saving it elsewhere. If I remember correctly, there was somewhere else that it's saved, but I'm not sure. But you can just use this file for now. So you can just extract the zip file, and it should open. So is everything good now? Should I start? Is everyone good? All right. Um, if anyone is having issues, this is your chance to speak before we start. All right. I guess not. So obviously, after you extract the file, just open it and open processing. It shouldn't be a very difficult installation. You literally just click, and then you have the IDE ready. And let me hide the other tabs, and this one as well, because we no longer need it. And this is where we'll be working. So let's start looking at the basics. Let me actually, I need this on my other screen. They're my notes for what I'm gonna do. So let's start off with the basics. So to summarize programming as a whole, you could describe programming and code, or actually programming. You can say that programming is basically giving instructions to a computer using a language called code. So this emphasizes what programming is. It's giving instructions to a computer using, actually, this is a wrong description, so it's to a computer using a language called code to create functionality. So functionality is basically something that serves a purpose. So that's the difference between coding and programming, is that programming has a function. It's not just like a set of instructions. It's like a function is basically something that changes something. The details are not very important, but programming is basically giving instructions to a computer using a language called code. So let's just think of it that way. So let's just look at that for now. Moving on, let's look at a great example of the most common, most popular way that like basically how everyone starts programming. And let me remind you that, okay, this is called a comment. I forgot to mention that this is called a comment. When you put two backward slashes together, it makes something called a comment, which means that that line will not be read by your computer. It's not even going to be seen. So that's why I can just write this. But if I were to write just anything, I'm not communicating, again, going by our description, I'm not communicating with my computer using the language of code. I'm just writing anything. This does not make sense to the computer. That's why you have to use the language of code. So the language of code can be thought of as the instructions, as we said. And as you can think of it as if you're writing like Morse code to your friend, for example, or you have a secret code that, you know, between you and your friends. You can think of it that way, but it's between you and your computer. And that is why you must use this code when communicating with them or with the computer. So looking at the most basic function, a function is basically an instruction. It's the print function, which a lot of you may be familiar with, where you write the word print, and in parentheses, and, actually let me just write the number 1 for now. Print 1 in parentheses, and you close it off with a semicolon. This is where you're using code to communicate with your computer to tell it to print the number 1. Now this is not going to print to your printer, so don't worry about that. it means that it's going to print to the terminal, which is down here. So this down here is called the terminal or your console. The console is the more direct term for this. Terminal is a little different. And now if I run the program, you can run your program in the top left here. So I want you all to try telling it to print the number 1 and then just run this. And you can see that it prints the number 1 in your console. So congratulations. If you do this, you're now considered a programmer. Not a very good one, but a programmer nonetheless. So congratulations to each and every one of you. You're now a programmer. I'm just kidding. There's a lot more to learn. So let's move on. You can do something. So of course, a lot of the time, you're not going to want to print the number 1. You might want to print the number 2, so you can just change that in there. And now it's going to print the number 2. You can tell it to print any number you like. So if you spam that, it's going to print whatever is in here. It's going to move it to the console. And you may be thinking, why would you do that? But of course, how you use it comes later. Now, what if I want to tell it to print my name? So I'll just say print Hassan. It's going to give me an error because it thinks it's a variable. Now I'm going to explain what a variable is in a bit, but for now, if you want to write words, if you want to write down a sentence, the computer will not interpret it correctly unless you put it between quotation marks. And the quotation marks, as in English, basically tell you that this is a quote. This is like a sentence or words, basically, that someone said. So if I tell it to print Hassan, it's going to print my name Hassan. But this would only work if you have these quotation marks. I'll explain why very shortly when we get into variables. So let me look at the plan. Yes, so this is called the print function. There are, of course, other functions, but for now, let's just keep to the print function because it's easier as a beginner to understand that. So does everyone understand how the print function works and what we're doing here? Before that, actually, or do you have any questions that you would like to ask? Come on, guys. I need more interactivity. Okay, everything is clear. Actually, this is not Java. This is a lower level language than Java, or higher level. I'm not sure which way does it go, but I'm not sure which way it goes. But I think it's higher level, which means that it's more restricted than Java. It's a Java-based language called the processing language, but it's very, very similar to Java, but it's a little easier, a little softer, you could say, and much more beginner-friendly. So in the programming community, Java has a reputation of being very, very difficult, but processing is much easier than that. All right. Now, moving on, since this is clear, let's talk about something called a variable. Now, if you guys are familiar with any other programming language, or if you're familiar with Python or JavaScript, this is going to break your heart, but in processing, you need to declare the variable type. So let's create a variable, and then I'll explain what we're doing to create this variable. So let's just create something called an integer, which is introduced using the word int, int. And I'll call this integer x, and I'll give it a value of 10. So what you're basically doing here what you're basically doing here is that you're declaring a variable that called x, and you tell the program the variable type. So now I'm saying that the variable type is an integer called x, and then you give it a value, any value you want. You actually don't immediately need to give it a value, but for now, just as good practice. As a beginner, you probably want to give it a value immediately, because you can get errors if you don't give it a value. So let's just create a variable called x and give it a value of 10. And inside my print function, I'm going to use the variable x. Just to explain how variables work. So now the program is going to read this from the top down. It actually does not do that in Java. It reads all the variables and then starts reading the functions. But you can think like the computer. So it reads from the top down. It sees this and it creates a variable called x. And then whenever it sees the variable called x, it's just going to look at the number. So a very common way to think about variables is basically ways to store information. So you can store names, you can store numbers, you can store you can store any type of information using variables. And if you get into object-oriented programming, it's going to start making a lot more sense. So now if I run this, the way the program reads this is that it reads the function, it sees that I have the variable x, and then it prints the variable x. The program, so I see in chat that you guys are asking, it keeps asking you to download Java. I think you probably need to have Java installed. Everyone should have Java installed. It's very common to have it installed, so I don't know, it didn't show up for me when I installed it, so I didn't know about that, so I apologize for not telling you to. But you can download Java from the website that 𝓟𝓻𝓸𝓰 sent. So thanks for that. Okay, so moving on. Let's talk about other variable types. So there's an integer. There's other variable types. So I'll start introducing them one by one. Or the three main ones at least. There's something called a float. And I'll call this y. I'll give it a value of 3.4. And then there's a third type called a string. But this type needs a capital S. The others start with a small letter. The reason for that is a little too advanced to care about, so for now just ignore it. So a string, I'll call this my name, for example. And I'll give it a value of course, I have to create it before I explain it, so I'll just say my name is Hassan. And basically the reason why we had to put the quotation marks here is because we needed a string to store the words we have. So words, letters, stuff like that are stored in strings, which you can then use wherever you want. So here I created a string called my name. And let me actually change this variable x to my age, for example. And I'm 18, so I'll put my age as 18. And this float here, I don't know what to call it. It's just a float. I don't really have a usage for it yet. I guess you could say that this is my height. And I am 1.83 meters tall. So you can put your height there. And the difference between these three, as I'll get into right now, is that an integer, as you might have noticed from the name as well, can only store integers, which are whole numbers, either positive or negative. So you can also store negative numbers here. But I did not do that because you can't be negative age. So it basically stores an integer. A float, however, can store decimal numbers because, of course, 18.5 is not an integer, so if you have decimals, you must store them in something called a float. Also called like a floating point value, but you can just think of it as a float. And the last kind of variable is called a string, and as we talked about before, you can basically put words in a string. It's not very, very important to know strings, especially for what we're going to do today, but strings are important when you want to get into algorithms. But for now, strings are not very important. So I'm actually just going to have it print my age, just so that it prints my age. And of course, as we did previously with the variable x, it now, whenever it sees this variable, it refers back to whatever variable you have here. Now you might be asking me, Hassan, why would I use a variable when I can just put the number 18 here? Because if I put the number 18, it's going to print the number 18 immediately. Now the reason for that, there are actually two main reasons why you might want to do this. Firstly, if you had a lot of code that depends on this one variable, number 18, and it's all the same, and then of course it's going to print them on the same line, but ignore that for now. What if I wanted it, what about next year? Would I have to change my whole program and change each one of these into 19 next year? I don't want to do that because it's going to be a lot of effort that I don't have to do. That is where the variable comes in. Rather than using the number 18 immediately, I can just use my age, the variable called my age, in here, and then it's going to, and then it's going to use the variable instead of the number 18. And this way, it prints 18, 18, 18, 18. And next year, I only have to change this one variable. And if I change that, it's going to use that there. The second reason is that variables can change. So let's say midway through this, while it's printing, I grow another year, or my age changes to 20, for example. Oh, my W key is broken, so ignore that. What if midway in your program, actually you don't have to declare it again, your variable changes. So this is how you might change a variable. And this is another way that variables are useful, is that if your variable changes, then how are you going to change the number 18? You can't change the number 18 unless you change it manually as a coder. But if it changes inside of the program, you're going to need to use a variable and change the variable itself. And if I run this now, you'll see that it prints 19, 19, 19, 19, and then it starts printing 20, 20, 20, 20. So yeah, that is why you want to use variables. We'll get into like different ways and different loops, but not in this course because this is going to be compressed. It's a crash course. But later on, when you learn about loops and using loops, you're going to really appreciate variables because they become very, very important. So now, moving on. Enough about variables. Let's start. I know that variables and looking at code like this without a lot of visuals can be very boring and not very appealing to beginners, especially me included. When I started programming, I didn't really enjoy it because I couldn't see and touch what I was creating directly. And that is why a lot of people are terrified to start programming, because it's not very easy to comprehend and understand. So now, I'm just going to delete all of this. And let's start with the fun stuff in processing. The fun stuff in processing, of course, is the visuals. Processing has a very strong foundation for visual effects and visual elements. So let's just start with a very basic function. So these are just the main functions you'll need to know when creating a project in processing. The first one is size. And what size does is that it changes the size of your screen. So if you noticed when I was running my program, you might have noticed this little screen that pops up. Now I ignored that until now for a reason, because we weren't really using that. But this screen is where is called your canvas. It's where you're gonna draw, where you're gonna change things. So if you remember in the other projects when I ran them, or so you run your project here, of course. When I ran my other projects, like random boxes, you saw that this screen pops up. Now you could look on the left and see like hints of what we're gonna do, but so yeah, your screen pops up and then it starts drawing whatever you want on the screen. Now there's a function called size, and I'm actually gonna write descriptions of the functions as notes for you guys. So there's a function called size, which changes the size of your canvas. And I'm going to change it to 600 by 600 pixels. So remember, this is pixels on your screen. So if your screen is 1080 by, or 1920 by 1080, which is the resolution of my screen, it might appear smaller than on another screen that is lower resolution. So here's the screen. It's 600 pixels by 600 pixels, and this is how you change the size of your canvas. So I'm just going to write a note, set the size of the canvas in pixels. I'm going to write a dash and just say that this is size, and then you put the width of your screen and then the height of the screen. So you can see that here. So this is your width and your height. I also forgot to mention something very, very important, so I apologize for forgetting to mention this. Some functions take more than one variable as input. So whatever is inside the function is called your input, or it's actually a parameter, or I forgot the other term, but I'm just going to refer to it as a parameter. And the end of a function, and a function always ends with a semicolon here. So you always must put a semicolon after your function, which basically tells the program that you're done with this line and to move on to the next one. Moving on, there's another function called background, and it takes 3 variables. Set the color of the canvas. And this is background. And this is where like some experience in computer graphics might come in handy, because this is where you put RGB values. So red, green, and blue, or RGB. And this basically means you control the different, the balance of colors here. So if you put 0, 0, 0, it means there's no color, which would be black. If I put this as 255, which is the maximum. Now I know this might be hard to get into and understand, but just follow along for now and you'll understand the details later. So if I put 255 in red and 0 in blue and green, this is going to be fully red, fully saturated red. And as you can see, it's fully red. Now, this is where I want you guys to guess. What would happen if I put 255 here? Can you guys guess? So Faisal guessed correctly. The screen or your canvas would turn green. So yeah, you guys all guessed correctly. Your canvas would turn green. And if I run this now, you'll see that my canvas is indeed green. Now, we get to some serious stuff, which might be a little confusing. But if I put 255 in both green and red, what is this going to give you? I want some of you guys to guess. You guys know how to program. Come on, you guys know RGB. This is not even a challenge to you guys. But yes, if you mix green and red in terms of computers, it gives you yellow. Now, what do you think would happen if I decrease the green? If I decrease the value that is green, what would happen? If I change green to 150, for example, what would happen? This might be, okay. You guys know how to program. So yes, here you're gonna shift the balance from yellow, because it's gonna be less green and more red, or in the balance there's more red, which would mean that it's shifted more towards red. Yellow shifted towards red is gonna be red, orange. It's not the easiest thing to comprehend, but you'll get used to the system and get used to how it works. Now, just as a final test of you guys' ability, what would happen if I put full blue and then 200 in red? Just last thing, this should be really simple. It's just basic colors. It's not as confusing as yellow. So yes, actually, if you mix red and blue, you get purple. And actually increase the blue because I want it to be a darker purple, but it's not as dark as I'd like. So maybe 100 in red would give me, yes, so this is a darker purple. And I really like this color, so I don't want to keep it because it's not really nice. Most of the time, if you realized, because of all the projects I showed you guys, most of the time I like to have my background be either black or white, but most of the time I use black. I just prefer the darker screen. I think it looks nicer. So if it's 0, 0, 0, it's going to be completely black. Now, or if you put this as 255, 255, 255, or full values, I didn't ask this time, but you gave the answer nonetheless. If you put 255, 255, 255, it becomes white. Now this is now these are the basics of RGB, how you can use RGB. And you might notice that it's tiring to put 255 all the time. So processing has a shortcut where you only put one value, and it gives the value to all of the different colors. And if I use 0, it gives me black. Let's do one more test. What if I put 100? Just 100? Or well, this it's the same as this. So if you have 100 of each, this is a tough one if you're not familiar with RGB. Does anyone have any guesses? Yes, actually. If you run this, you're going to see gray. So yeah, congratulations, guys. You guessed correctly. And yeah, enough of this. I'm going to make it a darker gray because it's less boring than black. So yeah, a very dark gray, and then we'll continue adding more. Now, this is where processing gets more interesting. There are a lot of functions that you can use to create shapes. So the most basic one would be rect, which creates a rectangle. And it takes 4 values, not just 3 or 2 like the others. But this kind of gets a tiny bit more mathematically involved. And I'm actually going to write what the values represent. Oh no, I'm not going to write them here. I'm going to write them in the comments. So let me just write that down and draw a square. Draw a rectangle, actually, not a square. Rectangle. at a position x1, xy. So this is your position on the screen, and I'll explain everything, so don't worry. Okay. I'll just write down what the function has, the variables that you input. So the first variable you put is your x position, the second variable is your y position, your third variable is the width of this rectangle, and your last variable is the height of the rectangle. And this is where the tricky part comes. So if I run this now, you'll see that it draws a rectangle here. You can see my rectangle here. Now I'll be very brief with where it's drawn, how it's drawn, because I don't want to waste a lot of time. We might not have enough time in 2 hours to finish everything, so it might be a little longer. I hope you guys don't mind. Moving on, the first value, which is the x value, is basically, I actually would have to open Paint for this. So Paint is one of the best software for explaining things online. So imagine this as your canvas. Give it a black background, or let's do dark gray as we have, darker. We have dark gray here. So let's try to get the same result here. I'll just draw a rectangle there. I'll move it down a little. And I'll give it a white color, just like we have in the program. Now, I closed all my tabs. Hid all my tabs, actually. I hate when it does this. I'm not sure why it does it, but it does it every time. Okay, so now, let's look at what the variables represent. So imagine that this is your canvas, and it has a width of 600 and a height of 600 as well. Now in processing, and in a lot of other programs as well, it's not just processing, it's kind of like the standard. Your grid starts from the top left corner, which is this point here, and increases as you go to the right. The x value increases as you go to the right, so this is x, and your y value increases as you go down instead of upwards, so it's kind of flipped upside down. So you'll actually see how it's flipped upside down as you get used to it. So it's flipped upside down. And basically this point here represents, this is your x value, and this is your y value. I'll call it x1 and y1, just so that it's clear that it's not the same grid, or the grid itself. So this is x1 and this is y1. And then, the same way that the grid goes, your width is going to stretch out to the right, so in this direction. So this is your width. And then your height is going to stretch downwards like that. So this is the width, this is the height. Just W and H because I don't want to write the whole word. All right, so now you have your width and your height. So now can you guys see how this reflects back into processing? So let's try changing this up a little, actually. So what would happen if I increased this from 100, I'll actually move this to the left so that it's easier to see. What would happen if I moved this, if I increased this to 300? What would happen? Just looking back at the graph, what do you guys think will happen? Just as an exercise. Um, so 𝓟𝓻𝓸𝓰 said it would go down. So let's actually try that. Let's make this 300 and it goes down. As you said, it goes down. So that's the correct answer. What if I increase it further to 400? Obviously, it's going to go down further. Okay, so let's speed things up because I don't want to take too much time on this part because everything is going to make a lot more sense once you get started making projects. So let's just change the y value to 100. And we change this to 400. What do you guys think this is going to look like? How do you guys think it's going to look like? You can see here, y value and x value are the same, so it's going to be like around here. It's going to be 50 wide, and it's going to stretch all the way down. Yeah, so it's going to be taller, not bigger. Well, yes, bigger, but taller specifically. It might appear thinner, but it's not actually going to be thinner. It's the same width, but just longer, so it looks thinner. So if I run this, as you can see, it's going to be a longer line. I increased the height, which is this, the fourth variable. So remember, the fourth variable is the height. So it's xy, width, height. So it's common practice to always put the x and the y and then x and y again, if you're using that. It's just common practice. Now what would happen if I increase this? What would happen if I increase the width? I said it. Obviously, it's going to increase the width. So if I change this to 200, it's going to be wider, as you can see. If I decrease the height again to like 20, it's going to be just a line like that. So this is how you can play around with it. And of course, you can then use variables here instead of just the numbers, just as you did with the print function. But we'll get to more advanced stuff like that later on. Now let's look at a few more functions. We're just going to do two more. We're just going to do fill and circle. So there's a function called fill, F-I-L-L. And here, it's exactly the same as background in the sense that it uses RGB. But the key here is that it actually changes the color that you fill things with. So it's just like editing the color in Paint here. Click that, and I change the color to whatever I want. But here you can actually you can put the RGB values here, or you can select it. So this actually gets back to processing. If you want a specific color, you can choose it here, or on any other program, and then put it in processing. But let's just make it a cyan box. So just full green, full blue. It's going to be like a greenish sky blue. Yeah, so you can see now it's a sky blue. I'm going to increase the size a little so you can see it. So let's do 300. Why not? So yeah, now you have this cyan box. So I'll just write down a note. Set the color, fill color for shapes. Now there is another, I'll just say RGB instead of red, green, blue. There's of course another one called stroke, and it's exactly the same, but it's the border color. So I'll just change this to 255. And of course, just like background, if you only put one number, it just gives it to all of them. So set the color of the border for shapes. Stroke RGB. And you can just look at that there. Yes, actually, it changes the default color that you fill with. So it's going to change all of the colors you fill. But the key here is that you can change it however many times you want. So now if I change the stroke color to white, you can't really see it, but if this was darker, you would be able to. So if I change this to like a dark red, you can see like that it's a dark red box, and then with a white border, just so that you can see the border more clearly. Okay. The key here is that you can change the fill color. So let's, again, make this I want it to be a dark purple. And we're going to introduce the final function we're going to look at, which is the circle function. And it takes an x, y, and z position. So I'll give it a value of 300, 300. And then you put the diameter of the circle. So I'll just give it a diameter of 300 for now. So draw a circle at a position x, y with a radius, with a diameter d, for example. And then the function, again, just like rectangle, would be x, y with diameter. I'm actually going to remove the last part again because I feel like it's misleading. So you put the x position, the y position, and the diameter. Now let me go back to the left. And yeah. Now, let's imagine what this is going to look like one last time. So there's going to be our screen. It's going to have the dark crimson box, which is going to be, I don't know, something like this. I'm just going to draw over the last one. And then it's going to have a big circle in the middle. It's going to be purple. And it's going to be like around here. I'm not sure of the exact size, but you can kind of guesstimate. So let's look here. It's exactly as we thought it would look like. And it's purple because we use the fill function again. So remember, you can use this however many times you want. Now I see that it's almost prayer time in the eastern region of Saudi, so Sharqiyya. I'm not sure when you guys want to take a break because I know there's people from all around. So let's take a break at 5:40, a break for 10 minutes. Actually, 5:40 until 6 p.m. Are you guys okay with that? So from 5:40 to 6 p.m. Is everyone okay with that? A 20-minute break to do whatever you need to do and pray. Is that okay? All right. So that's the plan. So let's take another 10 minutes to kind of implement a simple program using what we learned. Actually, there's still one last part we need to discuss. And yeah, on the plan, it's the last part of the basics of processing. Yes, thanks for asking that, actually. So 𝓟𝓻𝓸𝓰𝓻𝓪𝓶𝓶𝓲𝓷𝓰 asked, can I make the stroke thicker? And yes, you can make the stroke thicker by using a function called stroke weight. It's not very simple, but change. So yeah, you can change the stroke weight to. So people are telling me I read that wrong. Okay, Faisal. Okay, it's not Khattab. I'm sorry. I can't really read. That font is really small. I'm not sure how to read that. So is it Khashab or Khashab? English names, Arabic names in English are not too easy to read. So set the weight or width of the border for shapes. And it, of course, just like the last ones, it changes the setting. So if you want to reverse the original, you're going to have to change it again. So the original weight is 1. But so let's just try 1, and it's going to look exactly the same. But you can increase it to 2, which is going to be twice as wide. And let's just do 5 just for fun to see how it looks. So now you have 5. And of course, remember, it only draws it for the second one because you put the instruction after you drew the first blocks. So remember, this is procedural, or called procedural programming, where it starts reading from the top and it starts going down step by step. I actually no longer need paint, so let me hide that. I need it later on, though, so I'll keep it in the background. But yes. Okay, now we're done with this. I'll keep it here. You guys can take a screenshot or write it down really quickly. I'll give you a minute to screenshot it. I don't think the code would work properly if I send it in chat, so I can't do that. But you guys can take a picture or a screenshot and then refer to it later on if you need. Okay, so okay. Okay, if everyone's okay, we'll move on and we'll have a mini practice project before we get into the serious projects. Yeah, so 𝓟𝓻𝓸𝓰𝓻𝓪𝓶𝓶𝓲𝓷𝓰 sent a screenshot in chat. You have to download it to see it, so I'm not going to do that. But yeah. Okay, so let's create a new processing project. So you do that by clicking on File at the top left corner. This is also where you can save. So you can save projects here or save as. But you can also create a new project here. And this is where we're going to discuss two main things. So we're going to first start talking about flow. And then using flow, we're going to kind of do something. Create a really simple program. I'm going to try to rush it because we only have 9 minutes. So in processing, most of the time, you don't want to write code here. So just in the background, you don't want to write it there. You want to write your code inside of built-in functions. So everything is going to make so much more sense once you get to a higher level, but the basics are, okay, please don't annotate. So I have annotation on. So let me just turn off annotation really quickly. Right. And let me just clear the, because I believe someone drew something before. Yeah, okay. I thought it was on my screen, but it turns out there was a blue dot there. Okay. Moving on. Let's just create a really simple project to demonstrate something called flow. Flow in processing. Now I want you guys to just follow along. For now, just follow along and write this down. I'm going to give you a minute to write that down. And then I'll explain what it is, what it does, and how it's used. So these are the two main functions you're going to be using in processing. The first one is called the setup function. The second one is called the draw function. I actually want you guys to write it down before I start explaining, so I'll give you a minute to do that. So it's the word void. You might not know what that means for now, but just write it down. Void and then setup, and then empty brackets. Leave them empty. And then you have an open semicolon and a closed semicolon. Not semicolon, I'm sorry. Parentheses. I always confuse the two. So it's curly bracket or curly brace. And you can find that under your plus sign. So the open and closed one, closing ones. So for anyone that uses Python, you have to use parentheses here. It's not like Python. All right, if everyone's done, let's get started. So the first function, or the setup function, which is a setup function, as the name might convey, it's used to set up your program. And the draw function, the name is a little more misleading because it's used to loop things. I'll explain exactly what that means very, very shortly, and you'll see it real time how it works. So in your setup function, you will write instructions that set up your program. So the same instructions that you wrote here, for example, size and background, these two especially, you will most likely always have them in setup. Actually, background is used also in draw sometimes, depending on your project. So size 600 by 600, and as you can imagine, when you first run your program, it's going to run the instructions here. So if I click run, it's going to run it here. Of course, it's still gray because I didn't change the color. Now I can change the color to background 0. I'm just going to use 0. As I told you guys, if you only put one number, it gives it to all of the variables. So background 0, and then you have this black box. Does everyone have this ready? All right, if everyone has that ready, then let's move on to the next step, which is that inside of draw, this, on the contrary, loops indefinitely. So it loops as your program runs. So whatever instructions you have here, it's going to keep on running until you close the program. So now it's empty, so it does nothing. It's finished. But if I, for example, let's look at just a very simple example. If I tell it to print something, so just print hi, just like we did before we started using functions, print hi, and it's going to print it down here, of course. But since it's in setup, it's only going to print it once. But if I take this and put it in draw, you're going to see that it keeps on printing hi. Even though, okay, so it's still on, so it keeps on printing hi until I close the tab and it stops. So it's going to keep on printing indefinitely until you close the program. That is why it's so useful, because when you want to have an interactive program, for example, or if you want to have like something flow, like the projects we're going to create in a bit, you want them to be drawn there. Okay, so does everyone understand the difference between setup and draw? And by the way, from now on, you're not going to write any instructions outside of these functions. As a beginner, of course, outside of these two functions. As a beginner, you don't want to do that because it's not very good practice. Does everyone understand this right now? Okay, that's good. Now this is where the real fun part comes up, which is colors and interactivity. So let's just start off by drawing a circle. I'll just say at 300, 300 with a radius of 20. Now you're going to have this circle here, and it's going to keep on drawing. You can kind of see it draw over itself, but it's not really clear or important. The real impressive part comes when you change these variables into something that changes. When something changes over frames, it starts to make a lot more sense and it becomes a lot more beautiful to see and look at. For now, I'll use two functions that are built into processing called mouse x and mouse y. You don't really need to know this for the next project, so if you don't get this, just kind of go along with it. So there are these two functions called mouse x and mouse y, and these always refer to wherever your mouse is on the screen. So if my mouse is here, it's always going to pinpoint this point and draw a circle here. And you're going to see that as soon as I run this. So if I run this, my mouse is outside, but as soon as I come in here, you're going to see that it starts drawing over my mouse. And of course, I can't stop it yet. So you just have to kind of keep going until you feel satisfied. And then, I don't know, and then you can kind of leave from this. Oh, no, I ruined it. But this is basically it. You basically made paint here. Now, of course, it's still drawing the borders of the circles. You can remove that by using a function called noStroke, but I'm not going to do that because I don't care enough to do that. It's not important. Yes, so if you remember, so that's a good observation by Faisal. Okay. This right here, this last variable right here, refers to the diameter of the circle. So if I change this to 50, it's going to start giving me larger circles. As you can see here. Then I can just leave. Now I have this nice pattern. I actually, weirdly enough, I prefer the lines being over the circles. I think it gives it another level of, like, I don't know, realism, or I don't know, it gives it kind of a three-dimensional effect in a certain way. Yeah, it gives depth. Thanks for that term. I was looking for that exact term. Yes, this is how you can create a very simple paint program. So it's 5:40 now. It's still not prayer time for me, so I can't imagine that it's prayer time for the people in Riyadh and Jeddah. So that's a bummer. We can delay the break or not. How to make it to press so it can draw or go to mouse pointer. Okay, so if you wanted to only draw when you click, okay, so you guys want to delay the break, so let's delay it another 10 minutes. It gives us more time to look at this. Okay. Maybe I can even discuss something else, something extra. So if you wanted to only draw when you press the mouse, you'll have to use an if statement. We didn't talk about it, but basically an if statement is when the condition inside is true, it runs the code inside. So if the condition inside this bracket is true, it's going to run the code inside of the the curly brackets, or curly braces. So there's an if statement there. And there's a variable, just like mouse X and mouse Y, a built-in variable in processing called mouse pressed. And this is basically whether or not your mouse is being pressed. Don't think too much about the details. You don't have to know this right now. But now it doesn't draw until I click my mouse. When I click my mouse, it starts drawing. And you can see how it just draws these. But only when my mouse is pressed. Otherwise, there's nothing. And I can go here, click here, click here, click here, click here, click here, wherever I want. All right. Right, so let's have a short. I'm not sure when ferry time is in Jeddah, so let me. Oh wow, it's in 40 minutes, so that's a problem. Yeah, that's ferry time here already started. It's just starting now, so there's some overlap, or it's gonna cause a problem. And then there's people in Riyadh as well that are going to have a problem. So I don't want to have a 1 hour break because of that. So let's just have a 15-minute break or a 20-minute break, and then we'll get back and move on to the next project. I'm going to try to kind of keep it quick, and then there's going to be a break after the project. So I'm going to add a break after random box. The random box project, so that you can go pray quickly and come back. So I'll see you guys in a bit. I'll stop my screen now. I'll stop sharing my screen. And okay, so the recording's back. Okay, so let's get back into it. So now we're going to start the random boxes project, and I might not have too much time to explain because I really want to rush this because I don't want to take too long to finish everything. So really quickly, let's just write down the two main functions. So setup and draw, just like we did before the break. And I'll do the exact same thing, but this time I'll make it 800 by 800. If you have a smaller display that's 720 by 1080 or 1280 actually, I think. I'm not too sure. Not exactly sure what the resolution is, but if you have one of those displays, then you probably want to use 600 by 600. Now, Muhammad, wait up. We're going to look at the random function very, very soon. So size 800 by 800. I'm just gonna make the background equal to 0. And then in draw, I'm going to draw a rectangle at 100, 200, with a width of 300 and a height of 400. It's irrelevant numbers, they don't matter. So yes, just like this. Now it looks like this. Now obviously, this is not what we want. What we want is to have random values for all of these. And that way, every time it tries to draw them, it's going to draw with random values. To do that, I'm going to create variables. I'll just call this x and set this to 100, y, and I'll make this 300. It doesn't really matter. And w, which refers to the width, I'm going to make this 40. And h, which refers to the height, which I'll make 120. And instead of having these, I'll use the variables. So x, y, w, h. So now we just have these variables, just like we did before we started with the last project. In the beginning, we looked at variables and how you can use them inside of functions, because we use them in the print function. But this is the first time we actually use a variable inside rectangle. So of course, you can use the variables literally anywhere, and they will always refer to these. Now, as you know, or you might not know, we want to have random values for all of these. So I'll start off actually by randomizing the x and y positions, and then we'll look into randomizing the other two. So there's a function in processing and in most languages called random. So you just write down random. And this is a bit weird because we didn't do this before. But actually these need to be floats because random gives you a float. So just change these to floats if you can, if you will. There are ways to revert them to make a float into a variable, to an integer, but we'll not look into that. We don't have enough time to do that. But now, what we're basically doing is when we create this variable called x, we're assigning a random value to this variable in these parameters. So from 0 to 800 is how it is like the range that you have. So it's going to be anywhere from the beginning to the end of the screen. Now, if you have 600 here, of course you want to use that. Now, there is a variable in process. I don't want to get into the details, so I'll skip over the details. But there's a better way of doing this, but I don't really have time to go through it right now. If in the next course I do use this project again, I'll definitely get into the details because we have a lot more time then. So if you assign this a random value between this and that, what do you guys think is going to happen now? And Muhammad Mahdi, since you asked about it, what do you think specifically is going to happen? Yeah, so Ahmed Zemzemi already tried it. That's great. Of course, you can experiment as much as you want, with limits, of course. There are some pitfalls you don't want to try because it might crash your PC. But you can have your freedom because processing has those limitations set for you. It's not going to let you destroy your computer, so don't worry about that. So you said that it will go to random places when starting. That's true to a certain degree, which is that it's going to be only random in the x direction. So you can see the drawing, which is kind of weird, because you're only randomizing the x variable, the x value. Now, what you also need to do is do the exact same thing with y. And of course, you want to put the height. So if you have a shorter screen, if you have like a smaller display, you might want to use 600 for the height. And this way, it's just going to draw it just exactly like we discussed. I'm just going to draw it all over the place. Now, this doesn't look appealing at all. I think it's too fast. Now, there's something in processing called frame rate. So Faisal Khashab asked, why is it 0 to 800 and not just 800? So, okay, I have to write this down. So random gives you a random value from the minimum to the maximum. And it's going to be a random float in here, with decimals, of course. Yeah, so you can say that it returns a random number in this range, of course. So what I mean when I say that it returns a random number is that when you call random, so calling the function is basically using the function, when I say random, I have to give like its value to a variable or use it somewhere. You can actually just put it here directly, but I wanted to put it in XY just so that it's clearer for you guys. Now that's how you can give it a random value. Now Now, there's one more thing I want to do. So are you guys familiar with frames per second, or FPS, also called the frame rate? So if you guys play video games, you'll know that okay, so that's great actually. Random colors, you have to wait a bit for that. So if you guys are familiar with frame rates in video games, we're going to use something similar here, where we're going to set the frame rate. And of course, like, your computer will do its best to match that. So like, you can't just set it to like 20,000 and expect your computer to run that. There are limitations, of course. But I can set the frame rate using the function called frame rate, and I'll just make it 10, because I think the default is 60, which is why it was drawing very, very quickly. But if I change it to 10, it's going to be much slower. So it's only going to repeat it 10 times per second instead of the original 60 frames per second. So if you're not familiar with FPS, just follow along and you'll get used to it as you go along. So that's the frame rate. Frame rate to a value. I'm not going to write the rest, like how to use it. I just feel like it's taking too long. So if I change that to 10, you'll see now that it draws 10 of them every second, which is much slower than 60. So I think it looks a bit better. It still looks absolutely horrible because there's no randomization. It's all the same box, just in different places. So what you have to do now is I'll actually assign it a random value. Same thing with the height. And I'm going to give it a random value between -40 and 40. The reason why we have the negative is because I want it to go in either direction. So, for example, if this is your starting point, if you give it a negative value, it's just going to go to the left, like that. Or if you give the height a negative value, it's going to go up. You don't really have to understand this, so just ignore it if you don't get it. But basically, it's going to give you a random width between -40 and 40. Could go in either direction. And now if you run this, now we have fully randomized boxes. Now they might be too small, so I'll change this to 80. Okay, so now we have these. Now, of course, you can set the color of the boxes to one main color, but we all know it's more fun, a lot more fun to have random colors, so that it's different every time. Every box has a different color. It looks a lot nicer like that. So let's try to implement that. Now, I'll do it in a weird approach first. And actually, before that, I'm gonna compress this. So since we only use this variable in one place and we never change it, or it just feels weird to create a variable and then use the variable immediately. Or I'm not gonna do that actually. I'm just gonna do it like this for now. But let's get into fill. So I'll just fill the screen with, or change the fill color, as we said before. I'll also make it random between 0 and 255. So as we know, the maximum is 255 for colors. The default maximum, at least. And what's going to happen, as Muhammad Mahdi tried and noticed, it's either going to be white or black. Now you could like this, and I do actually like this. It has a certain appeal to it, but I want to do something different. I want to have many, many colors, just like the background we had, like that I showed you guys earlier. I don't actually have it open, so can't really show it. So what you have to do is introduce something new called HSB. And if you're familiar with colors, you'll understand it immediately. But the hue, which is this value here if you open Paint, it's basically where the color is. So if you look here, I'm changing the hue at the top here. And the hue is basically like the color. So if a hue of 0, as you can see at the bottom here, with my mouse there, it's completely red. As you increase it, it starts changing the color, like it goes to yellow, goes to blue, goes to green. And this is the value you want to randomize, not the other one. Not the brightness, which is white or black or whatever. Now you could have random green, random blue, random red, but that's going to give you very diluted colors. It's not going to look very nice or as nice as HSB by changing the hue. Now there are two ways you can do this. You can either create an HSB to RGB calculator, or you can just use the built-in system, which is what we're going to do. It's not difficult to create the translator, but it's going to take time to understand it. Okay, so I don't want to explain it too much, but when you change color mode, so if I say color mode HSB, changes RGB to HSB, and then in brackets I'll just say hue, saturation, and brightness. For now, I'm not going to explain it because it's going to take too much time. So for now, just follow along. It's still out of 255. I didn't change the maximum, but I'm going to give it a random hue value, which is the color. So as we said, it changes everything that used to be RGB into HSB. So now it's going to give it random hue, and then 255 for saturation and 255 for brightness. As you remember here, we changed the default from RGB to HSB, or hue, saturation, and brightness. You'll have to do more research on this to really understand it. But as I said, I don't want to spend too much time on it. But that's how you get random colors. It's going to take way too much time to discuss it in depth. But I don't want to use that time on this project. All right. Does everyone more or less understand how this works, especially like the randomization, the boxes? Not necessarily the colors. I think the colors are more difficult to understand than the rest of the project. There is another thing I can show you, which is something that's called an HSB color picker, which is a tool. So it's this. So this is a tool that helps you visualize hue, saturation, and brightness. Now, of course, this is not from 255 because it's a different system, but basically you can see that the hue, which is this round slider here, lets you choose the color as you go around. And then the saturation is how strong that color is, which is like its saturation, how saturated it is. And the brightness is between full brightness and completely black. So Muhammad Mahdi said it does not work, so make sure you write this down, this part's down. And then, of course, fill here, down here. You also need this. So these are the two lines that are going to make it have completely random colors. So as I told you guys, changing just a line or two completely changes how the project looks. So from black and white to colors and everything. Is it still white or black? Oh, make sure that you're only randomizing the hue and not the saturation and brightness as well. Because if you only put this, it's just going to be... you don't have to put brackets here. It's only 255. unless you have to put random as well here. So you would have to write that down, not just the brackets. And if I run this now, you'll see that I really don't like this because I like bright and vibrant colors, but if you want that, whatever that is, you can have that like that. That actually still looks nice, I think. Just not as nice as the other one. So yeah. But as I said, we don't want, I personally don't want it to randomize these two. So it's a good observation that you're playing around with like colors and everything. So actually for everyone in the recording, I would recommend that you pause here and really try to play around with the project before you continue to the next one. But for those of you that are attending live, too bad. You can't really pause me, can you? So yeah, we'll have to do the next project. Okay, it's good that it works. So just try to digest this and take your time later on. But now we're gonna get to a more involved project for those of you that might be a bit more experienced in programming. This is gonna be the real eye catcher for you. So let's create a new project. And of course, exact same thing we had before. I'll actually give it a canvas size of 800 by 800. As usual, I will give it a background color of 0. Frame rate, I'll leave it alone. And then I'll leave color mode alone, and then you guys can add colors on your own later on. So for now, it's just going to be white and black. But then you can might be a little more involved in that, but you can quite easily. So it's open here. So this is what we're going to create. I'm going to simplify it a little so that it makes more sense, but you can add colors later on. For now, it's just going to be white and black. So it's going to be like this, just a white line drawing. And you can add colors later on. You might have to do some math for that. But I don't want to. Maybe we will, actually. At the end, maybe we will. So let's get to it. So we have void draw. And before that, actually, I want to talk about circles, because I want you guys to understand the basic concept that we're going to be using here. So if you look at a circle, you have a center point for this circle, which I'll draw here. And then I'll just draw the radius anywhere there. And then I'll also draw two perpendicular lines, one representing the x-axis and one representing the y-axis, just like so. So I'm going to actually start writing letters down. So that would be x, and this would be y. I'll just call this capital R for the radius. And then, of course, here, you're going to have an angle, which we will call A. Don't worry. It's a mathematical project, so if you don't like math, tough luck. You got unlucky. But let's just write down some basic equations here. Some equations that we can observe. It's not going to be difficult math. So I just want someone to tell me, to help me along, and help me calculate the two variables that we will mainly be focusing on. So you can just say, given R and A, so using these variables, find X and Y. So what would X be equal to? Actually make this. So what would X be equal to? So using R and alpha and A, or alpha, how would you calculate X? Using some trigonometry as a hint. Does anyone have any idea? We have a doctor in mathematics on the call, so I don't know, is it too difficult? Okay. Okay, thanks, 𝓟𝓻𝓸𝓰. So yes, you're actually correct. R is going to equal to, or X is going to equal to R times cosine A. Now, of course, cosine and sine are built into processing, and you can use them anywhere, which is what we're actually going to do. And then Y. So yeah, Muhammad Al-Layl also wrote that down. The same answer. And then for Y, Y is going to equal to the other counterpart, yes, which is R times sine alpha. Now, of course, I put times here because I don't want to use X, but this basically means R multiplied by cosine A. And it's actually the same symbol we use in programming. So this is how you can find the X coordinate and the Y coordinate of any point corresponding to this angle. The idea here, which might be difficult to comprehend for a beginner, but this is why I want you to really focus on this. So what we want to do right now, we'll start off by trying to draw a circle. And how we're going to draw this circle is that we're going to draw a point with this value of alpha, or A, and then we're going to change A and draw it for the next value of A. So we're just basically going to draw the point for A equals 0, A equals 0.1, A equals 0.2, until you loop around the circle. So of course, we're going to use radians, or actually, I'll actually use a converter to convert from degrees to radians, just to make it easier to understand. I forgot that it uses radians, actually. So what we're basically going to do is draw all of these points, and then you're going to see how it looks like a circle. When you draw all of these points all around the circle, that's how you're basically going to draw the circle. In most cases, I would connect them, but connecting them is a whole other story. So let's finish the bare bones first, as I said. So what we are going to do, it's not the easiest thing to explain as well, but we are going to create a variable called A. And of course, we're going to have R, which is like the radius, however big we want it. But for this A, we are going to start off with A equals 0, and then change A ever so slightly so that you move on to the next point and draw a point there. Do you guys understand? So there is a way to change variables, basically make a variable equal to itself, and like, how can I say this? to itself plus a small value. So you said that you forgot how to use setup and draw, so here it is. You can see it on the right. So I'm thinking how I could convey it so that you guys can understand clearly. But I think the best way to understand it is to actually start by working on it. So let's just create a float x. Actually, also create r, and say that give it a value of 300. But I'm also going to create a variable called x, and x is equal to r times cosine a. So it's the exact same thing. And this, of course, is literally cosine. So it's as if you're putting the formula into code. And let's just say that a is equal to 0 for now. And then float y equals r times sine alpha. And then down here, I'm going to draw a small circle. Now this is just to draw a point, basically, so ignore like the fact that it's a circle. At x, y, with a diameter of 5. Okay, you'll see how to automatically increase the value of a, so just wait a second. Now you can't really see it because it's up here. There's one more thing you need to keep in mind, which is that you don't want x and y to equal to this exactly. You want to kind of move it to the middle of the screen. So you want the center of the circle to be the center of the screen. You need some geometry for that, but there is a function that we'll use which just changes the center. So instead of the center being at the top left corner, the center is going to be in the middle of the screen. And that function is actually called translate. And then you just put how much you want to translate. So how much you want to shift it to the right and how much you want to shift it down. So here I'm going to put 400, 400, which is half of the width and half of the height. And if I run this, now you can see that it's here. This is the point. And then what we want to do, as we said, if you refer back to this, we want to increase this ever so slightly, so it's like that, then like that, like that, like that, like that, like that, until it completes a full circle. And we're actually quite close here. But we need to do two main things really quickly, which is that the variables, usually constant variables or variables that you want to change, you have to put them outside. So I'll just put them above draw, like so. That is because I don't want to create a new variable every time I run draw for A. So you asked about how to make it so that when you press your keyboard something happens. We'll get into the details later on. There's a full course for processing that we're gonna create. So if you're worried about that, then wait a little. But you can search online how to do that later on. But we're not gonna do it here, because this is not a full course. It's a crash course. All right, so firstly, do you guys understand the idea that we have? Does everyone understand more or less what we're trying to do, what we're trying to figure out and create? The idea of having the variable here with an angle of 0, and then we just tell the program, okay, now that you drew it for the angle being 0, change the angle. Change it again and again and again and again. Now, you could use a random number, but it's not going to be good. It's not intuitive, so what you want to do is start it off with 0, and then after it draws the circle, or at the end here, you want to say that A is equal to A plus 0.01. Now, this is very confusing, because how can a variable be equal to itself plus something else? It doesn't make any mathematical sense. It's a bit of a paradox in a certain sense. But that's not how programs work, how computers work. How computers work is that they see the instruction that you are changing the value of A. It's not it's solving a formula. It's just saying now that I'm changing the value of A to be equal to a new value, and the new value is equal to A plus 0.01. And if you want to make it better, you can create a float called B, which is equal to A plus 0.01. So you change that, and then you might want to like just put B there. Now this is kind of redundant, but it's gonna work. But I'll actually backtrack. So that's just a way that you can think of it. But I'm not going to use it. Faisal, actually, you said that you asked whether or not we need a while loop for that. And if you haven't realized, we do actually have a while loop, basically. We have the draw loop. So this is the draw loop. The draw function runs continuously, never stops. So it's like a while loop, but you see every frame separately. So do you understand that? So it's basically a loop, but it keeps looping. And you can see every single individual frame. Now, if we run this, as expected, you can see it moving. Now you can see the line moving. So this is exciting. Now we're starting to get somewhere. Right. So this is how you would draw a circle. Does everyone have any questions before we move on to having some cool stuff happen with the circle? Right, no more questions, so I'll actually do something again, and I'm going to say that the radius r is equal to the radius minus 1. I just want to do this. I just want to see what happens if I decrease the radius every frame. And if I run this again, you'll see that unlike the first time, the radius starts increasing and it draws in a different way. So we went from the circle to this weird shape here. But I'm actually going to remove this because it's not really like our project. You could change this, make it something like r is equal to... Actually, you would need a new variable for that. So let's just quickly change this to r small. And then the big R there, that's what we're going to mess with. And I'm going to say that this big R, for example, sine A, R times sine A. If you guys, you have to say that it's a float. Now what we're doing is that we changed it so that the radius is actually 300, but the radius we're using is a bit different. It's going to be a little weird. It actually draws a circle like this. This has to do with math, but... Okay, that's confusing. I'm struggling to find how to explain this to you guys because I've worked with it so much that I understand it deeply, but my problem would be like conveying it to you guys. Okay, so why I wrote lowercase r is because the radius I want to use here. So we were able to successfully draw a circle, and it worked perfectly. But if you remember, the project we want to create is not that it draws a circle, but that it draws a circle with a changing, like, with basically like a wave radius that goes like this, right? You want it to go in and out, in and out, in and out. Actually, accidentally deleted that. Now, how you would do this is basically by having the radius change. I'm thinking about how I can explain this clearly, which is why I created a new variable that I called r. R small. And r small is the value of the actual radius, but r capital is the radius we're using. I should probably have another term for it instead of r. It might make it a little difficult, so I'll call it L. L is this length here, so this is L. And then I'm going to have it like go in and out there. Now this is not going to make sense unless I put something else here. The cool part comes because if you look at, okay, let me explain this in a different way actually. If you think about a sine wave, so if you, now if you're not very good at math, I hope this would help, but if you look at a sine wave, like this, it's basically like this. What you basically want is to draw this sine wave. The way you can think about it is that you want to draw this sine wave and wrap it around the circle. The way I'm going to do that is by having the radius change every frame to kind of be like the sine wave, but while rotating at the same time. So if I have r equals L, like we did before, if I just delete this part, you're going to see that it draws a normal circle. But what we want to do now is have the length, or the radius here, change every now and then. We want to change it in some weird way. Now you can play around with this. Like for example, something I can think of is how, like making it a spiral by saying that r is equal to, I'm actually remove that. R times 0.99, which is basically going to like decrease it ever so slightly. Not going to work actually, unless I change this to R. Yep. So if this was the case, you'd be kind of drawing the it's going to make sense when you run through it. Okay, that's way too much. But basically what you're doing here is that you're just decreasing R by a little tiny bit every frame. And that's why it starts spiraling inwards. But that's not what we want. We don't want it to spiral inwards. We want it to have a sine wave going out and inside again. So the way you can do that is by having it equal to L plus a small value, I'll just call it 50, I'll just make it 50, plus sine A, which is the angle we have. And if you run this, you'll see that you're not going to see it very clearly because there's one last step that you need, which is changing this, multiplying the A by a number. So what's going to happen if you say that this is equal to 3 times A, for example? Or let's do 7. That means that this is going to oscillate or go in and out 7 times before it reaches the beginning again. It's more mathematically involved again, but that's the whole project. That's the whole concept behind it. Now, as I said, it's a lot more mathematically involved than the other one. And you can count the tops. So this is one bump, 2, 3, 4, 5, 6, and 7. So it's 7 as the same as this number here. That actually gets me to the end of the projects. I'm not going to keep on going through it. I know it's a very hard project to understand, but I would encourage you. I would encourage you guys to kind of keep exploring it and keep trying to play around with it until you get some nice results, something nice out of it. Actually, one last thing that I already did, but I forgot to mention. If you put a decimal here, it shifts it every time it goes around so that it kind of tries to loop again. But I want you guys to discover that on your own and like kind of create the relationships on your own and like discovering what each thing does. So I'll leave that to you guys. Anyways, this brings me to the end of the crash course. I apologize because I know it was not supposed to take 3 hours, but it still took 3 hours. It was quite long. Too long than I anticipated. So I apologize for that. But I would really, really encourage you guys to keep exploring this. There's a lot of potential. Even if you think that, for example, you're bad at math or not very good at creative thinking, you can still learn all of that stuff through programming. So I would really, really encourage you guys to learn everything. This course was a bit rushed, especially at the end. So I apologize if some things were not very clear. But you can rewatch the video. Of course, I'll upload it. You can go through it a few times. I'm also going to record other... we're going to host other courses that are going to be longer and not as rushed, so it's going to make a lot more sense. So yeah, thank you guys for attending. I hope you learned something from this. I hope you really enjoyed programming, you could say. And for any of you interested in joining the Coding Cave, I'll post the link for the application in chat in a moment. And yeah, that's basically it. Thanks everyone for coming, and yeah, I'll see you later. If you have any questions, you can ask them now. So, yeah.